Hello everyone, my name is Daniel and I'm an informatics student at the Technical University of Munich. Welcome to my tutorial on reinforcement learning for bipedal gait generation. But first, let's see what reinforcement learning is capable of. This is Google DeepMind Atari game playing. So the game only has as input, not the game, the player, the artificial player, the image that we all can see, and has as a reward the score of the game. So after only 2 or 4 hours of training, it is already on a level of expert gamer. But let's see something more interesting and more related to what we're interested in. Bipedal walking. So the same strategy, only visual input, and the reward is the forward distance. You can see that this agent learns to walk through a rather complex environment, and this is without any previous explicit programming. This is all learning by itself. Okay, the Bellman equations are the starting point of such algorithms because they were used for solving the optimal control problem. What is that? So for going from point A to point B, we need a policy, which is a sequence of steps or a mapping between the current state and an action. And this sequence of steps should take us to our desired goal. So these two functions you can see here, v and q, just think of them as value and quality. An important result from psychology, the law of effect by Edward Thorndike. This famous scientist had a famous experiment, of course, where he would put a cat in a box and the cat would have access to a mechanism for setting itself free. The first try of the experiment would take the cat long enough to find a way to get out of the box. But by repeating the experiment, the cat would need less and less time to repeat the actions that would set itself free. Think of training a dog. If you give the dog some treats, the dog will most likely repeat the tricks you want to teach it. If the dog is chewing your shoes, for example, a small punishment would make it, perhaps, hopefully, cease this bad behavior. So, in computer science, reinforcement learning is learning a behavior without explicit information about correct actions. This means that the agent, the AI, only has information about the final desired goal. So we define a reward only for the final state. The agent is not guided along the way. It has to find the optimal, the right policy on itself by interacting with an environment through actions. So an environment is defined by states, actions, transitions, and a reward. Okay, finally, our simple robot that we'll use in this tutorial. It is defined only by 16 states, 4 states for each leg. So each leg can be up or down, front or back. Also, our robot can perform 4 simple actions: move the leg up or down, back or forward. By knowing the states, the actions, we can shape the transition matrix, where each value in the transition matrix gives us the next state by applying the right action at the current state. One of the algorithms used in reinforcement learning is called policy iteration. So at first we guess some control policy, and then we perform several steps. So at each step we try to improve a little bit our control policy by computing its value function, and then at each step we choose the best action that maximizes our value function. After several iterations we stop, and that is our hopefully optimal control policy. Another algorithm called Q-learning uses the quality matrix instead of the value function, and we again iteratively try to compute this quality matrix. We update it at each step. So at first we choose some action. We are in initial state. We try to choose an action, and this action can be chosen randomly. This would be an exploration step, or it can be chosen greedy as the best action in that step, which would be an exploitation strategy. After we take an action, we see what is the next state, and we compute the maximum reward we would get into the next state. And we update, as we can see in this formula, the quality matrix. And we move on to the next step, next state, and we do this t times. And at the end, we choose the optimal policy as the action at each state that gives us the maximum future reward. Okay, so I wouldn't want to upset these guys, so let's go into the code. So this is our MATLAB code. We have 3 scripts, main and one for each of the mentioned functions. The policy iteration function starts by guessing the policy, and then at every iteration we evaluate the policy, and then we generate new policy by choosing at every state, in every state, the best action. And at the end, the last policy available in the last iteration is hopefully the best one. The Q-learning algorithm starts by initializing the quality matrix as zeros, and then at every iteration we either choose a random action or the best action possible. We update the quality matrix at every step, we update the policy, and we move to the next state. Let's see how these perform. So we define our actions, our states, our transition matrix, and our reward matrix. So we have a positive reward for moving forward and a negative reward for moving backward. And let's see how the policy iteration works. Oh, this doesn't look that good. Maybe if we increase the number of iterations, we would get a better result. And we did. This looks like a proper gate. Now let's try the Q-learning algorithm. This looks a bit odd, but it still moves forward. So this is an example of a hardware implementation of reinforcement learning for gait generation for a spider-like robot. As you can imagine, this type of approach for a bipedal humanoid robot would be quite dangerous for the hardware, because failing mode would mean the actual robot to fall, which could damage the robot. And here you can see the same principle of trial and error. So the spider-like robot tries different policies until it finds the optimal one that allows it to locomote forward. So before ending this tutorial, I want to show you some more results from Google DeepMind on bipedal walking using reinforcement learning. And this gait is actually really similar to what we obtained in our last experiment in MATLAB, so only using one leg for forward bipedal locomotion. So this is everything from my side. Thank you everyone for watching, and hope to see you next time. Goodbye.